Hello and welcome to today's webinar, Beyond APM, Achieving the Benefits of CICD and Cloud Native. I'm Jay Lyman. I'm a senior analyst with 451 Research, part of S&P Global Market Intelligence. And I'm pleased to be joined today by Pat Conte and Michael Declerk. I'll let them give brief intros.
Hi there, I'm Michael Declerk. I'm the VP of Engineering here at Opsani and super excited to be having this discussion today.
And I'm Pat Conte. I'm Chief Commercial Officer here at Opsani. Both Michael and I have worked with the founders of Opsani in different ways and in different other companies. So this has been an exciting journey getting optimization out to the marketplace. Really great to be with you, Jay.
Excellent. So let's jump right in. We'll be talking today about some higher level objectives of DevOps and CICD. And the data points that I'll be referencing come from our Voice of the Enterprise DevOps surveys that we run twice a year. And we also track some things that we're presenting, challenges and benefits of cloud native, the role of APM and what else is needed to realize some of those benefits of cloud native. And we'll talk a lot about observability and how it's key and how we think it's more than sort of hype and there's something to observability. So let's jump right into it. And this is some of the data from that survey that I mentioned. And in our most recent survey, for the first time since we started this survey in 2019, so in 6 surveys, we saw the top desired outcome of DevOps and CICD was improving that quality of experience for users of applications and services. Previously, we've seen that organizational agility and flexibility, speeding up time to market is always important too. But I think this is interesting because it marks how I think there's been a realization of how improving digital experiences has become very critical. As critical maybe as going faster, right, and managing IT more efficiently. So some of the sort of hallmarks of DevOps and CI/CD organizations, especially after they've deployed DevOps for a good amount of time, or they've spread it to more of their teams and applications, they're starting to look at other benefits, and a lot of these more business sort of based, and also leveraging analytics and AI and ML, as well as observability in order to know how well infrastructure and applications are performing, and how well customers are responding or not responding to those applications and services. You need that observability, and so that's a big part of what we're going to be talking about more on the webinar. Let's go ahead and look at another data point. This is basically the biggest challenges of cloud native software. Security and compliance, not too surprised to see that there. We typically see security and compliance as among the biggest concerns of enterprises, rightly so, given some of the things that happen with security breaches in headlines. Cost is always an issue, all right? Organizations are always looking to drive efficiency and reduce their costs. And even though there's a lot of interest and adoption of cloud native, it's still there's still some concern around the budgetary matters of it. And you also have sort of a skills and talent shortage that can contribute to some of those cost challenges. And then complexity, we still hear stories about the complexity of software like Kubernetes. And I guess this is another area where observability and the collection and analysis of monitoring data and logs and traces and other metrics is really that observability is key to addressing some of these challenges. Cost, to know where your efficiency is and where your costs are going, and complexity, again, I think observability can help organizations simplify and drive efficiency there as well. Let's go ahead and look at some of the cloud native benefits. Now, these are some of the things driving cloud native. Efficiency leads there, and we see a lot of containerization where organizations are slicing up VMs or slicing up servers with containers, the same way that we did sort of slice up and drive efficiency of server hardware servers through VMs. We're seeing the same sort of thing happening with containers. Security, right? I know it was listed as a challenge, but there's also a security upside to cloud native software like containers and Kubernetes. You've got a lighter weight application packaging that makes for less attack surface. And I think a lot of the challenges lie in sort of the high security bar set by VMs with multi-tenancy. But containers are evolving, and I think security will increasingly drive cloud native adoption and be less of an impediment over time. And then of course, developer speed and productivity. Those are sort of, again, core to DevOps and cloud native benefits. And anytime you can help your developers go faster and you can help them focus on new features, new products and innovation, the better off you'll be. And I guess we also see, again, here's where observability sort of has a role in helping organizations, not only improve their internal processes, but increasingly, again, looking at those end user experiences and customer satisfaction and other sort of business metrics. And here we're just sort of considering, we ask what are the most important tools in your DevOps implementations. And interestingly, we see analytics, AI, and ML at the top. Previous surveys, we've seen the move to the cloud sort of prominent with the public cloud providers. But I think we are starting to see, along the lines of what I just said, improving both internal processes and software releases, and also improving those user experiences by leveraging analytics, AI and ML, correlating some of this telemetric data and driving some analysis of those business-driven objectives. That's what we're seeing there. And of course, the second category there, monitoring, logging, and alerting, always ranked pretty high on our list of most important tools, because organizations do need to sort of know what's going on with their infrastructure and their applications. And that can be a starting point, but there's much more required. And then I guess, again, this is sort of a check in the market of whether observability is just hype, a marketing term, or whether it's something that organizations are really wrapping their arms around. And it seems to be the latter. We do see pretty significant adoption with more than 40% of organizations using it, and especially when you consider organizations in discovery or planning to implement in the next few months, or in the next year to 2 years. So and I think again, knowing what infrastructure and applications are doing, ensuring performance, resiliency, and efficiency, and again, sort of making sure that you have a good handle on how are these applications and services being consumed, and what is the experience of the end users. And there was a time when software developers and IT operations teams cared more about the elegance of their code and their scripts than they did sort of the end user experience. But sort of breaking it back to where we started, that really is a top priority for organizations now. It's a huge part of that digital transformation, and it's part of being an agile organization with the flexibility and resiliency to respond to changes in the market, whether that's new technology like cloud native, whether those are security incidents or vulnerabilities, or whether it's a global pandemic that seems to drag on. So that's a sort of an example of some of the what the landscape looks like a little bit. I think now we're going to move to some perspective from the Opsani folks, and probably a good place to start would be if you could talk a little bit about what Opsani does.
Sure, Jay. Thanks so much. And thanks for that. Thanks for that overview. Opsani is a company that has developed using machine learning and artificial intelligence, a platform for optimizing cloud applications. What we mean by optimizing is taking the key parameters of those cloud applications and constantly tuning them so that the result is you're always getting the best performance, you're getting the best reliability, and you're using the least cloud resources, which translates typically into the lowest cloud spend. So those are really the three things three results that people get out of optimization. And what's happened over the course of the last few years is that customers have been leading us very much towards cloud native applications and application technologies. And as a result, most of what we do today is around Kubernetes. Whereas when we started, a lot of it was in hybrid environments that were, VMs, different kinds of VMs, maybe different kinds of container environments as well. But today, it's very clearly that the target is around Kubernetes and customers wanting to be cloud native.
Great, and it would be also good if you could tell us where Opsani sort of fits in this market. It is a very sort of complex and crowded market in some respects. So,
yeah, that's a good point. And this slide sort of represents the spectrum, if you will, of different solutions for optimization, from the observability part, which is all the way over on the left, to all the way over to the remediation part, which is really where we sit in. So if we sort of think of these different functions as being, what would be a function within a company, then you can sort of represent the APM as security, right? They're always monitoring, they're always looking, they're looking for health, they're looking for for performance metrics, trying to make sure that everything is okay. And then you've got the accounting function, and there you're really talking about really cloud management platforms and like Cloud Checker, Cloud Health, et cetera, that really are trying to make sure that everybody fits within an established environment for how they're going to spend the money that is that's aimed at cloud, different sizes of instances, what projects they get assigned to, and things like that. And then you've got the real estate folks, and here you might look at somebody like Spot, which is always looking for the lowest cost workload, whether it's in the same cloud or whether it might be in another cloud. And then with the ability to potentially move that instance that you're working on into one of these other areas where it might be less expensive. So none of these things are what we do, but we work with all of these. We're in this newer area that we call the computer science area, if you will. And here you've got a couple of different areas. So if we sort of think about the you've got a couple of axes here, and then the vertical axis is cloud native would be sort of at the top, whereas legacy technology would be at the bottom, and then on the horizontal one, all the way to the right would be autonomous, and all the way to the left would be would be not automated at all, or less automated. So where we fit in this whole scheme of things is, the ones in the lower left are older technology optimizers. They do use AI in some cases, but what they typically do is provide a recommendation engine. And what they'll do is they'll provide a set of a register of choices that then the SREs from that company can use to go ahead and make changes to the infrastructure for the application settings, whether it's CPU memory or replica count, or it could be other things as well. And so they'll give them a set of choices as to what changes to make. But it's static. And so once the company takes those, by the time they actually put them into effect, given the CICD world that we're all in, many cases, the environment's changed, right? The company's pushed new code, or traffic has changed. It's either spiked or it's dropped or whatever. So those static recommendations could be out of date. So that's one area, and you know, those optimizers are out there in the marketplace today, and we do see them from time to time. In the upper left, you've got Google, you've got Google Autopilot, and really this is a service that's being offered by Google for optimization, and it's a combination of technology and people and smart guys. We are really the only solution that is autonomous, continuous, and really can operate on large scale numbers of services all at the same time from one from one machine learning backend. So that's where we fit in the scheme of things. We're certainly not on the security side, the accounting side, the real estate side, and we're definitely different from the other players that are in the what you call the computer science area.
Well, hey, you're talking hybrid cloud, automation, AI. Yeah, you're speaking my language. So let's maybe talk about how it works.
Great. Let's go ahead and go here. And I'm going to ask Michael to jump in and tell us about the architecture and how everything fits together.
Sure. Thanks, Pat. So as we've been talking, earlier, Opsani is really concentrated on being a continuous, at scale autonomous optimizer. So, we've taken on a lot, but we're going to break it down into some pretty simple levels to work through the architecture. So at a very high level, right, you have a service level objective. And as Jay was pointing out in the survey earlier, we've gone from where people care about, how shiny their code is to what the actual customer experience is. I've worked at a number of large scale services where we measured, customer experience in millisecond responses, and we went like double-digit millisecond responses. Right, that was a reason to throw an alarm and start, getting people out of bed. So the first thing we want to look at is what is that, service level objective that's going to give the best customer experience, and typically in a lot of cases that's latency, and it can be, kind of defined in two ways, either prescribed, like I said, say you break double-digit milliseconds, or it can be auto-discovered. There are some, services that when you roll them out, you really don't know how good it should be, right? So what you want to do is potentially over time have the optimizer, as it's going through its tuning, figure out, hey, your best, SLO might be 11 milliseconds versus 20. So that's part of what we do. So we take those tunables and those SLOs that we've either been told by the customer or we've auto discovered, and we give that to our optimizing engine. At that point, what we need to do is start getting, basically the observability. So we're going to talk to performance metrics that are coming out of the application space, whether that's pods or containers, native. And in our case, what we do is we have what we call main and tuning. The main is like your larger production fleet, and tuning is a single instance. And what the optimizer service is going to do is work with that tuning instance to run through multivariable, analysis across, multiple traffic flows within a set time period to determine what is the optimal configuration for your space. And this gets even a little more complicated when you think about it, that most applications are not a single application. It's not just a database, or it's not just a message service, and it's not just a front end. It's typically all three of those working together. So the optimizer is actually talking to all of those, getting the performance metrics from each component, and then looking at the SLOs to determine, hey, what's the next area I should explore? The big advantage of AI ML here is that the exploration is going to happen in non-intuitive areas, right? We will all intuitively say, hey, if you give it more CPU or more memory, that's going to be better. AI ML doesn't do that, right? It's going to explore the boundary conditions that we don't define the best. And then it works in concert once it finds the best solution, kind of with your CICD and your monitoring solution. So, if you're running Jenkins or Harness or something, once we've got a recommendation, it can be fed into that for auto promotion. The key part being here is that we're going to do this continuously. So as your traffic changes, as your code changes, as different parts of even the underlying infrastructure in your cloud provider changes, the optimizer is going to be seeing all this and trying to determine a new optimal, giving that as a promotion recommendation to your CI/CD system and allowing it to be promoted autonomously and continuously into your fleet. And the kind of way we look at this is we do single instance or pod tuning. So we look at how do we right size a single component in there. The next part is, well, your traffic is going to change over time. So given that we have an optimal pod or instance size, how do we basically help you determine what's the correct horizontal spread, right? Based upon traffic. Should you increase or decrease your count and take that down? And then within those two areas, we can do, instance proactive auto scaling. So look at your traffic patterns and determine that for a set period of time, whether that's an hour in the day, a day of the week, a part of the quarter, where those instances should be changed, as well as adaptive load profile tuning, which is pretty much the same thing, but over a larger scale time. So at a high level, in a nutshell, that's kind of what we're doing and what we're trying to provide, that at scale, continuous, autonomous, tuning for your cloud environments. Pat, did I miss anything in there? Jay, any questions?
No, it makes sense. But when you mention sort of the CICD, that's another sort of far-ranging space and market. Maybe you guys could tell us how you fit into CICD.
Yeah, definitely so, Jay. That it's a key area for us. Before we leave this this slide, I just wanted to talk a little bit about the sort of the connective tissue in the middle there, the northbound connectors and the southbound connectors. So we connect into whatever's collecting the metrics. So it could be an APM like App Dynamics or New Relic or one of the other ones. It could be the ingress controller like Nginx, or it could be something in the open source like Prometheus or whatever the case may be. So we've got the southbound connector there. We've got the northbound connector into the that goes into the CI/CD platform. It could be Jenkins, as Michael said, or it could be something like Harness, or it could be the Kubernetes service that's being offered by the cloud vendor. So and all of this is really designed to add speed to a process that could slow down. It's designed to be very fast service, but when you start to have to create those connections on the fly, things can slow down. So that's one of the reasons why we've built this out of machine learning so that we can operate at machine speed. So to your point specifically in terms of how do we fit into the CI/CD world? The upper part of this diagram is something that our customers have really told us is the experience they have in general as they're building their code and they're pushing things out to the marketplace. Somebody says we need to build something, VPGM or an application owner. The developers grab something out of the Git, they hack on it, they hand it over to the DevOps team, which does the build, test, and integration, and then sort of pushes it over to the SREs to get it ready for production. It gets pushed into production. All this happens very, very quickly. Not twice a year anymore as it used to in the old days, but in some cases, monthly, weekly, or maybe even faster than that. So what happens once it goes into production is invariably something happens with the code. There's a performance lag, a fault, or a delay or something. And so what you have to do at that stage of the game is you've got to use your tools. You've got to try to find out what's going on. So you use your monitors, you try to apply load, you look at your APM logs, and ultimately the first thing you do is you over provision, right, to try to soak up the problem. So you're gonna scale out, and of course you're gonna overspend when you over provision. Next thing you're going to do is go back to the test logs and see, did I miss anything there? And you're making guesses, you're forming hypotheses. Eventually it goes back to the developers. and a hot fix is hacked, and then it goes back through the conveyor belt again. And so, as we've looked at this, we've asked our customers, is this what their experience is? And virtually 201, they've told us that this is normal life for them in the new CI/CD world, right? So, so the question would be, how can we help? And where we help is, if we take a look at that same environment, the most important thing that we can do is we can apply ourselves to production. So that technology that we talked about, tuning the key parameters, the CPU memory, replica count, possibly Java-based parameters and others. When we apply that in the production area, the result is going to be, you're going to get the best performance, you're going to get the best reliability. Typically, performance is looked at in terms of latency, reliability in terms of error rates or other metrics, and you're going to get the lowest cloud spend possible for the SLOs that you've set or the objectives that you've set. So that's where the most benefit comes from. However, there's actually, in the CI/CD environment, there are some other places where we can plug in. Most importantly is in the test phase. And so if we go back into the DevOps area and we plug in and test, we can actually right size the solution as it's coming through the DevOps environment. And what the advantage here is, the DevOps guys don't have to over provision. They don't have to just sort of throw as much resources as possible at the instance to try to get the first thing that works before it goes through to the SREs. In fact, they can right size the instance in terms of CPU memory, replica, or any of those other items that I mentioned. They can right size it so that when it goes to the SREs, it's already pre-sized. The SREs that then don't have to guess, well, how big should this be, or how many replicas or whatever. You've already got an optimized version coming through. So this is really shifting everything left, saving time, definitely saving money, and giving you the chance to have a better performing product much faster in the overall process. So this is really where we fit into the CI/CD world. And again, we've been dragged to the cloud native space from that hybrid space, and really a lot of this has to do with making sure we're working well in the container space, and also especially with Kubernetes. So let me just take a breath here and see if that makes sense.
Well, it does, and I think that it makes sense that you've sort of been pushed toward cloud native and Kubernetes, given that I think the top day 2 challenge I hear about Kubernetes is monitoring and troubleshooting, right? And that's where this sort of new paradigm, this new software, Kubernetes, I mean, it's still relatively new in the enterprise, even though it's been around. We see growing adoption. It still comes with the challenges, and it's sort of a different way of doing things. But anything the organizations can do to be able to zero in more rapidly and more precisely on what's going wrong, the better off they're going to be. So yeah, it does resonate.
Excellent.
Well, you mentioned the integration with APM, and it'd be good to hear a little bit about how that works, how you integrate and expand on APM.
Yeah, we can give you an example of what this looks like. I know this is a little bit isometric here, but essentially, we need to get the SLOs for the application. We can get them from an SLO manager like a service mesh manager, or we can get them from the APM, or we can get them from the application itself. In many cases, customers don't have SLOs set; they don't know what they should be. And by observing the application using our machine learning, we can actually come back and say, this is these should be the service level objectives of that particular application. And that's a benefit that we can bring to the table for customers. But in any case, we need some SLOs that we can measure against, and we can get them from one of 3 areas, either, again, the service mesh manager, the APM, or we can divine them from looking at the application. The way machine learning works is, we try a bunch of experiments, we try them over time, we do it from getting the application metrics, and then we reach an optimal, and then that optimal is a new set of settings that then, as Michael had talked about, can be promoted into production once we've reached that optimal. So how we would integrate with an APM would look like this stack here, where the metrics would come from the cloud application to the APM. The APM would then share them with us. We would then turn around and do the remediation and optimization of that application. It could be remediation if the application was starting to go out of bounds. It could be an optimization if we were looking for best performance, best reliability, and lowest cloud spend. So this is really the way just at a very high level, an integration with an APM would work. And in fact, we've got an example of one that we've done in the real world. It's not the only one, but it's a good example, and that's one that we've done with AppDynamics. This diagram here represents what a normal application optimization would be. We're all the stuff in light blue. The AppDynamics stuff is in purple, and you've got an Ingress service on the left, and you've got our backend that SaaS service is our AI that lives in the cloud. And Michael, maybe you can just flesh this out a bit and talk about what's actually happening here.
Sure. So as Pat mentioned, the light blue components are what Opsani provides. So assuming the purple is your standard application, what we add into the mix is a component that we call Servo that provides the glue in between the tuning pod and the rest of the application and talks to our backend service. So the tuning pod is what's running the experiments, the AI ML. As Pat mentioned earlier, it communicates with Servo to provide those results back to our AI ML in the cloud, which then, based upon those results, will provide back the next experiment or an optimization. But to provide all that, we hook into the APM, in particular in this instance, the AppDynamics, to get the metrics. So to get our service level objectives, our SLIs, everything that's necessary to do the tuning pod and observability work. As Pat mentioned earlier, we could get it from AppDynamics. We could also be getting some of those metrics from the Ingress service, which might be Nginx. But it will run through a period of time where we're running experiments across a number of traffic, servers communicating back to our cloud service. And at the end of a set number of observations and experiments, we will come up with a recommendation. All this runs within a standard Kubernetes cluster or selected namespace. And once it's done, right, we can then provide that recommendation either to a Kubernetes native deployment, right, to change the configuration, or to some other CICD. But all this is running within a cloud native Kubernetes environment.
I think a couple things to amplify there and maybe to add in are that it only takes us about a half an hour at the most to install Servo, put up the tuning pod, and connect Opsani to the customer's application. So it's very, very simple and easy to get up and running. In fact, customers can do it themselves via our self-service portal. But if they need help, we certainly can jump in and help them. But it only takes 20 to 30 minutes to get up and going. And then we go into sort of a pre-flight mode where we double check everything before the plane takes off, if you will. And then we start the experiments. And typically it takes between 20 and maybe as many as 100 scans or iterations for us to get to an optimal. And we may get to several optimals over the course of time, just based on traffic changing or other things that may change in the environment. But typically within a day or a day and a half, you're going to find an optimal that will significantly improve the performance, reliability, and cost environment of that application. It's a very fast process to get to a result. And this is also one of the reasons why customers have been pulling us towards Kubernetes. They want a fast time to value. and other kinds of services and other things that they've looked at might have taken weeks or months. Maybe even a proof of value or a proof of concept might have even taken weeks or months. We can typically get the entire thing done, installed, and get to an optimal within a day and a half or so. So the ease of ease of use and fast time to value are a couple of things that we've solved for here with the solution.
Yeah, the other part, Pat, that I did bring up earlier in this one is as you were talking about resiliency and reliability. Part of that is once we've come up with an optimal, we can run a full verification for, on the tuning pod across these different traffic patterns. So before we provide this recommendation, whether it's better cost, better performance we actually run a verification stage, right? So there's a very much a safety factor built into both the experimentation to not cause harm in the environments and to provide something that is going to be better than what was running before with regard to resiliency and reliability.
Yeah, so when an optimal is found finally, we've done it by tuning the tuning pod, which is getting traffic, the same traffic as the production pods are, but it's not a production pod. Once we've found optimal, then the customer has the choices to whether or not they want us to auto promote so that all those settings get assigned to the rest of the application, or whether they want to push the button and promote. Most of our customers choose the manual promotion for at least a while until they realize that we're doing what their SREs would do if they had an army of them, and if those SREs could operate at machine speed. So once they've sort of figured out that we're doing what they would do, then they allow the system to do auto promotion, which really is where the autonomous part of what we do comes in. So,
Yeah.
so Jay, is that all that makes sense in terms of how it works and how we sort of plug in?
Yeah, it does, and it makes me sort of think about something I've been hearing a lot this year, and that is a lot of organizations, want to leverage Kubernetes, but don't want to be a Kubernetes company, right? And it's all about sort of leveraging these services, and then also being able to sort of manage that alongside your sort of existing deployment. But yeah, I mean, it makes sense, and I think again, it's all about sort of achieving some of those benefits from automation and efficiency and optimization, without necessarily having to, not many companies can find an army of Kubernetes, operators or SREs, and if they could find them, they probably couldn't afford it. So that's been something that we've been seeing. Organizations are sort of addressing a lot of that lack of skills and experience in this area by leveraging services and a whole variety of them, sort of back to hybrid cloud and hybrid IT. But I guess one of the other area that would be worthy of discussion is, what can customers expect? What types of results are you seeing? You sort of walked through a typical deployment, which was good, but what are sort of the gains that customers could expect?
Yeah, that's a great question. And real quickly before I show a result that we've achieved with a customer on an actual, in fact, one of our APM customers with an actual service, I did want to reflect real quickly on what you said about sort of the labor issue. We see the same thing when we talk to customers. Not only do they not have enough SREs or enough Kubernetes people, they have trouble keeping them. Because as soon as somebody gets up to speed, it's like somebody comes and snatches them away. Yep. The same thing's true in the at the vendor side as well. We've got to be real careful. We keep all of our smart guys in the boat because there aren't enough of them out there, and so that's why automation. That's why what we've done is try to create something that's that replaces a lot of that stuff with automation. And our objective is not to replace the SREs, but to allow them to do what they really should be doing, which is getting code ready for production and pushing stuff out, as opposed to messing around with the tuning pieces, which are which can be arcane and have to happen a lot. Yeah. So what we have here is is the report. the optimization report for an actual service. This is an individual service within a cloud. So this particular customer has a cloud of services that look for end user metrics. And so you can see the traffic at the top. You can see that traffic over time. So you can see it was done over a period of days. When everything was concluded, we achieved an optimal that we were able to save them approximately 50% of the cloud spend for this service, which is a multi-million-dollar service. In addition, we were able to cut their latency by about 50%. So we improved their performance. And I think probably more importantly than anything, if you look all the way on the right-hand side there, we reduced their error rate by about 90%. Now, in this particular case, this was a service that had a lot of errors. In some cases, your service might be close to zero. In that case, we're going to maintain, right? If the performance is solid, we'll maintain that, and then we'll look for the best use of cloud resources. But in this case, you can see where we on the left-hand side at the lower area, you can see what we did to achieve the optimal through a series of experiments. We reduced the CPU from 6 to 2.125 cores. Memory was able to stay the same. And this is this is not atypical of what we might have to do for a particular application. In fact, the opposite may happen as well. It just depends on how that particular application is architected. You can also see in the lower right-hand side, we recommended reducing the instance count from 4 to 1. So because you didn't need all those replicas to actually achieve what you need to achieve for the service level objectives.
Great. And I know you also have a demo for us to see Opsani in action.
Yeah, we do. Thanks very much, Jay, for setting that up. And let me just talk a little bit about what everybody's going to see. So again, this is a bit isometric here, but in the particular demo that we're going to share with everybody, we've got an application. That application is Bank of Anthos, which is a Google test application for Kubernetes, multiple service application, and it's running on Kubernetes. We actually are getting service level objectives from Cisco Service Mesh Manager. That integration isn't shown in this particular recorded demo, but what happens is we're getting the application metrics from AppDynamics, and then when we make changes to the application, we're sending that information via alerts back to AppDynamics, so they show up in the AppDynamics UI. So we've got sort of bidirectional integration with AppDynamics on this, and we're able to continuously optimize. One of the things about AppDynamics is they alert when things get one standard deviation away from normal, and then they alert even more when they get to 2. So it's sort of a green, yellow, red. When they get to 3, then you're in the red. Our objective in doing the optimization was to actually never let those applications get into the yellow or the red, but to let everybody know that they've been optimized, so that they can see that both their observability is working and the optimization part is remediating. So with that, let's go to the demo, and I'll just click on this and we'll run for a couple of minutes here.
In this video, we're going to look at optimizing an application using AppDynamics business transactions and the Opsani optimizer. Here, we'll be using the sample application Bank of Anthos, instrumented with AppDynamics agents. Here, the application flow map is shown, which maps out all the tiers and nodes of the service, as well as all the business transactions found. To examine these, we'll go over to the left-hand panel and hit Business Transactions. And we can see various ones found, such as deposit, sign up, payment, etc. Here, we're interested in optimizing the payment business transaction, so we'll go ahead and click that. And then we can see the flow map for this particular business transaction and how it routes through front end, ledger writer, balance reader, and the database. We can also go to the Tiers and Nodes Explorer and see how each tier and node is mapped out in the console. To get started with the Opsani optimizer, We'll follow the same deployment instructions as shown in the previous video, taking care to select the template for business transactions when creating a new application. Once we do so, the optimizer will begin in pre-flight mode, going through a couple of steps to ensure health checks. Then it'll begin in optimization mode, and we can go to the console and see how it's progressing. As data points begin to flow into the optimizer, we can check how the parameters of each step are affected right here in the console. Here, we can see that for the first step, the tuning profile mimicked the main settings and that the cores and memory were exactly the same. We can get a more detailed view by checking out the graphs view and selecting which information we'd like to see presented. As the optimizer proceeds, a plethora of settings will be attempted. The tuning node will apply a different combination on each step, and in addition to seeing this in the Opsani console, we can also investigate from the AppDynamics console. Here, we'll click on Business Transaction Performance, then Business Transactions, then our target business transaction of payment. We can see that for each step the optimizer proceeded, a new time window was created for that particular node in the metric browser. This is useful for seeing how particular metrics change over time with different parameters, color-coded according to that particular step. Here, we'll investigate how the tuning node's metrics changed over time using calls per minute. In this window, we have a selection of about 5 steps in which the optimizer was changing the resources of the tuning node, and we can see exactly how the calls per minute were affected. These are separated in time and color-coded to help see the difference. We can also see other metrics such as latency and errors per minute. All in all, the optimizer will proceed for about 100 steps, which in this particular case took about 24 hours to run. We can head back to the Opsani console to see exactly how this proceeded and how the metrics were affected over time, as well as find the optimal and best performance over cost ratio result. Let's go ahead and investigate the optimal result and see what parameters the optimizer found. For the CPU, we can see it found an optimal of 0.625 cores, and for the memory, 0.375 gigabytes. This is a substantial reduction from the initial settings of 1 core and 1 gigabyte. However, the application maintained performance at these reduced settings while reducing cost. In addition to the performance, cost, and optimization score graphs available in the dashboard tab, we can also go to the summary tab here on the left and see a different view to find that the optimizer found an optimal of 48% savings at these settings.
Going to say it'd be good to tell folks, how they can learn more.
Yeah, thanks. Appreciate that. So I do want to make a quick point. We are the only solution in the marketplace that's using AI and machine learning to continuously and autonomously optimize these cloud applications. There are a lot of other solutions out there, as we discussed earlier, and what we're doing is pretty unique. And I think you can see that. I think the audience can see that by what we've shown so far. So here's our offer. For 3 months, we're going to allow you to use the production software free of charge to optimize as many services as you want. If you have a particular application, for example, there might be 8 or 10 services, and you want to optimize that application, we'll go ahead and do that for you, optimize it, and allow you to use it for up to 3 months. At the end of the 3 months, if we've provided you a good optimization, then you can buy a license for the software, buy a subscription, an annual subscription, and we'll do it at a rate with an 80% discount for you. So if you do this free trial, we'll offer you an 80% discount, and that means $100 per service per month. You can pay for it with a credit card, with a PO, whatever whatever works for you. Again, you can get up and running in a very short amount of time. If you want to, if you're interested in trying this out, then look at the address at the bottom, opsani.com/signup, and we'll be happy to work with you and help you. So for a limited time, we're going to do this three-month free trial. As many services as you want, we'll help you get up and running. You can use our architects if you run into any trouble or whatever. We'll give you full support as if you were a paying customer. And we think that we think that this will be a great experience for you.
Thanks, Pat. And we're sort of we're nearing the end here. But I guess in closing, I would just say, you know, some real, I think, resonance with the things that I cover. And I really see automation, optimization, and observability, you know, all sort of playing an increasingly large role in these disruptive trends that I cover of, you know, DevOps and cloud native. And so I'm sure there's more to come, but this is you know, right sort of the intersection of a lot of my coverage in the DevOps and what SREs are doing today, and sort of the challenges and the benefits that they're dealing with.
Well, definitely appreciate your guiding us along here, Jay. And you know, I might say that you know, what we're trying to do is take the observability that's available in the marketplace today and extend it with optimization. What you're really able to do is move from what we could call application performance monitoring to application performance management, and that's really, you know, something that requires the remediation capabilities that we have to be added to the application performance monitoring part that the APMs do. And this can help you all the way through from your CICD all the way to your production. And that's our objective, is really to help customers with these complex areas using automation. Maybe I'll just ask Michael if he has anything else that he wants to add or anything to wrap up here from our standpoint before we show your disclaimer.
I think you've covered it very well, Pat and Jay. Really appreciate you taking, you know, the time to walk us through the survey and then allow us to show how we can help address a lot of the rising problems that are occurring in the market.
Yeah, my pleasure. Enjoyed the discussion.